Welcome to video 2. Video 2 is going to be page 2 of the Unit 4 test. This page is worth 11 total points. Let's show where the points are distributed. We have question number 4 is going to be worth 2 points. Question number 5 is going to be worth 4 points. A, B, C, and D are each worth 1. 6 is worth 1. Question 7 is worth 1. And question 8 is worth 1. And question 9 is worth 2. So there are where your 11 points are going to come from on this page. So let's take a look at question number 4. It wants to know, is 60, 91, and 109 a right triangle? These are the lengths of sides. Notice that there are no degree measures on them. So these are the length of sides. And it just wants to know whether this is a right triangle or not. And when we were trying to prove whether something was a Pythagorean triple, we had 3 steps. We had to prove that it was a triangle. We had to prove that it was then a right triangle. Then we had to prove that they were all integers and it was a triple. This just wants to know whether it is a right triangle. So I only need to do one of those 3 steps. I need to check and see if the 2 smaller sides, 60 and 91, if I were to square them and add them together, if it equals 109 squared. Okay, let me grab my calculator. And there we go. 60 squared is 3,600. 91 squared is 8,281. And if I were to add those 2 things together, they add together to 11,881. And my question is, does that equal 109 squared? Well, if I do 109 times 109, I get 11,881. So yes, the 2 are equal. So yes, this is a right triangle. So you got a point if you said with the work, I did need to see yes, and I did need to see the work to support it for both points. All right, number 5 says use the diagram below. Write ratios in simplest fraction or radical form. Remember to reduce your fractions. So you do need to reduce the fractions here. So because this is a right triangle, I'm going to use SOHCAHTOA. So SOHCAHTOA here, I'll write it up here. SOHCAHTOA. And use SOHCAHTOA. And for parts A, B, and C, you'll notice they all say find the sine, cosine, and tangent of angle A. So here's angle A. Makes 24 the opposite, 26 is the hypotenuse, and 10 is the adjacent. All right, so let's do A, B, and C first. So the sine, we can see in SOHCAHTOA, sine is opposite over hypotenuse. So 24 over 26. And then I have to reduce that. They are both even, so it will reduce. Half of 24 is 12. Half of 26 is 13. And 12 over 13 no longer reduces. So I was looking for 12 over 13 for part A. For part B, cosine is A over H. Adjacent is 10 over hypotenuse, which is 26. Again, they're both even, so it'll reduce. Half of 10 is 5. Half of 26 is 13. So 5 over 13. Tangent is O over A. So O is 24. A is 10. Again, they're even. So half of 24 is 12. And half of 10 is 5. 12 over 5 does not reduce. Now as I get to letter D, this wants me to find the sine of B. Okay, so I'm going to go back and erase that off my triangles. Here's angle B, which makes 10 the opposite now. 26 is still the hypotenuse, and now 24 is the adjacent. So when dealing with angle B, the sine is still O over H, but now the O is 10. H is still 26, and that reduces to 5 over 13. Some people may remember that because A and B are complements, that the sine of B would have to equal the cosine of A. So you could have just looked up at the answer to part B and knew that it was the same for part D. Each one was worth 1 point. If you failed to reduce your fraction, I just took half off. Okay, question number 6 says use the trig ratios to find the value of x, round to the nearest tenth. That is 1 decimal point. All right, so 33 is my angle. So x is opposite, and 14 is the hypotenuse. So I'm using O and H, so I know that that is the sine. So the sine of the angle, sine of 33, calculator will tell me what that is. That is equal to the opposite, x, over the hypotenuse, 14. And if I need to solve for x, I'd have to multiply both sides by 14. So 14 times the sine of 33. That is equal to x. And if I put that into my calculator, make sure you're in degree mode. 14 times the sine of 33 is 7.62. It says round to the nearest tenth, so that second decimal point is a 2, so it will not change my 6. So 7.6 is your answer for x. And question number 7. Here's my angle. X is my hypotenuse. The blank side is opposite, so 10 is adjacent. So I have A and H, so that is cosine. So the cosine of the angle, 17, is equal to the adjacent 10 divided by the hypotenuse, x. This is one of those cases that we talked about many times, where the variable's in the denominator. So I'm going to do the old switcheroo here. Cosine of 17 and x will switch places. So x is equal to 10 is still on top, but now cosine of 17 is now my new denominator. And I'm going to type that into my calculator. So 10 divided by the cosine of 17. And again, round to the nearest tenth. So this is 10 point, and it is 4.5. So that will round me up to 10.5. Number 8, same idea here. X is my angle, so 12 is opposite. The blank is the hypotenuse. 29 is the adjacent. This one wants me to round to the nearest degree. So O and A is tangent, so the tangent of x is equal to the opposite 12 over the adjacent 29. Now to solve for x, I have to get rid of tangent. So I get rid of tangent by using the inverse. So tangent inverse of that fraction, 12 over 29. And it wants the nearest degree. So I go second tangent in my calculator, 12 divided by 29. And I get 22.4. So round that to the nearest degree, it would just round to 22 degrees. And then number 9 says list 2 Pythagorean triples, and there are a bunch of them. There are too many of them to list them all. I'm just going to give you the 2 that come to mind for me the fastest. What I would have to do is check to make sure that a squared plus b squared does equal c squared. We talked about 3, 4, 5 is maybe one of the most common. 3 squared plus 4 squared does equal 5 squared. And then another one, 5, 12, 13. Also 7, 24, 25. There are a whole bunch of these that you could have listed from. That is the end of the second video. The next video will break down page 3.